In our last lesson, we learned that data types tell Python what kind of information you're working with: numbers, text, true, false values, Boolean, or collection of items. So we'll go more into why you should really care about this, as I'm going to show you exactly why data types matter so much in programming here, and some things that happen when things go wrong. When data types don't match what Python expects, your program doesn't just politely ask you to fix it. It might crash, it might give you error messages, and even worse, sometimes it might not give you any error messages at all, but just produce completely wrong results. So let's take a look at our first example. Let's say you're building a program to calculate something. You might write something like this. So first I'm typing example 1, and we've got the assignment operator, which is the single equals sign, and then quotes with 25 inside of it. And I'll do the same thing with example 2. And then we're going to total those two up with a simple math operator, adding example 1 plus example 2. And then in order to look at this, we need to do a print statement. Since we're using a variable total, we don't want to use these quotes. We just want to put total right there. And then I'm in VS Code. We'll go up to the top right and press the run button. And you can see the results. 2555. So 25 plus 55 equals 2555. Well, you know that's not true if we're talking numerically. So these quotes are an issue right there because we've told it should be a string and not a number. So let's just get those quotes out of there. And then once the quotes are out of there, we'll run our program again. See what result we get. And now you can see 80. So 25 plus 55 is 80 is accurate. But that's an example of where the program wouldn't have failed. It still would have run, but the totals would have been all wrong. Let's take a look at our second example. We'll call this forgetting what type you're working with. The input function is what we're going to type in here. We'll type user input assigned to input, and we'll say enter your age. That's the prompt for the user. Whenever we perform a user input call here, Python prompts the user and then waits for their response. And then we'll say if user input is greater than 18, we'll put that colon, and then we'll just type a print statement. Print user is greater than 18. So now you see we ran the program again and we get an error. So it didn't silently fail this time. The program just crashed. This is because the input function always gives you text. It always gives you a string, even if someone types a number. So 100, like I typed, is of course greater than 18, but it was attempting to compare a numeric value with a string value, and that just wouldn't work. So let's just take a look at how we're going to fix this. We're going to type int, and we'll put the input inside of parentheses so that we're wrapping it in int, and we're going to run that. Now you see it's not crashing. Let's test it. And we can see it works. It says the user is older than 18. So let's just go ahead and add also an else statement so that in case they type something that is less than 18, so we can see it really works. And we'll put our print statement here, just saying user is younger than 18. And then we'll just run that. And I'm going to say user is 5 years old. And you can see user is younger than 18. It works. So the issue is we had to transform it to a number, an integer. So for our next example, we'll call this assuming Python can read your mind. It makes me think of the Rasputina song, Diamond Ring one, where she says, all I expect from you is to read my mind. So we're going to type price. We'll assign that a string value of 19.99, and then we'll type tax and assign that price times 0.1. So you see we get an error here. Even though Python can multiply text by a number with a string repeater, it cannot multiply text by a floating type number. So you have the type error. If you're wondering why Python doesn't just figure all these things out automatically, why can't it see that a 25 in quotes is obviously a number? Well, there's a lot of context around that. And so Python prioritizes being predictable over being quote unquote helpful. Sometimes being helpful can get you in trouble. If Python tried to guess what you meant, sometimes it would guess wrong, and that would create bugs that are much harder to find. Instead, Python follows clear, consistent rules. When you understand these rules, you can write code that works exactly the way you expect it to. This is a good thing. Languages that try to be too smart about guessing often create more problems than they solve. When you understand data types and use them correctly, several great things happen. First, your code becomes more reliable. You'll get fewer mysterious bugs and crashes. Second, your code becomes more efficient. Python can optimize how it stores and processes data when it knows exactly what type it's dealing with. Third, other programmers can read and understand your code more easily. When someone sees that a variable is clearly defined as a number or text, they immediately know what operations make sense. And fourth, you'll write code faster. Instead of debugging weird behavior later, you'll prevent problems from the start as much as you can. In our next lesson, we're going to go ahead and learn about the type function, which is a great tool for debugging. This function will tell you exactly what data type any variable is. You can catch these issues before they become problems. After that, we'll explore how to convert between different data types safely. You saw an example of that. So you can handle situations like getting text input from a user but needing to do math with it. Understanding data types isn't just about avoiding errors, it's also about becoming a more confident and effective programmer.